Poppy Crum is the chief scientist at Dolby Laboratories and is an adjunct professor at Stanford. At Dolby, Poppy is responsible for integrating neuroscience and sensory data science into algorithm design, technological development, and technology strategy at Stanford. Her work focuses on the impact and feedback potential of new technologies, including gaming and immersive environments such as AR and VR on neuroplasticity and learning. We're very excited to have Poppy here at this conference for the first time. Welcome.
I'm going to give you a heads up. I am coughing a lot, but I'm past everything. It's just in case I have to drink some water, hang with me on this. Whoa. Anyhow, all right. Thanks for having me. There's so many beautiful themes here that are very common. I think we're going to step into a little bit of the entertainment space for just a little bit and see how I think there's a lot of convergence happening in these fields. When you look at this image, what comes to mind? Like just anything. What's in that internal experience you're having when you look at, this picture from NASA? What? A whole Earth catalog. Awesome. I've had people say climate change. Depends where your mindset is. No. Planet. Any? Precious. I like that. So about a year ago, I was at the planetarium in DC with my 2.5-year-old daughter. And we're watching Journey to the Sun, and everything's very quiet. And they do a big pan out of the Earth, much like this. And my 2.5-year-old, as loud as she could, yells, "Minions." All right? And very loud, but what's really beautiful here is it makes complete sense when you realize that her experientially established prior of this image is coming from this image. So as far as she's concerned, she sees a picture of the Earth and thinks of little yellow people, but it's one of these beautiful representations of how we all have a different internal experience of the same physical information. And that information, our internal experiences are being driven by our biology, by our experientially established priors, and by our expectations. And ultimately, one of the most important things our brain is constantly doing is integrating this information and weighting it predictively to enable us to have action that is dependent and enables us to be successful in a competitive environment. And fundamentally, we've been able to model the behaviors with different models, machine learning models or Bayesian integration models, but underlying all of that is this notion that the statistical distributions of the environments we interact with, whether we grew up in a village in Afghanistan or a town in the Midwest or Europe or a city like Kathmandu or New York, where the colors, the contours, the environmental pressures put on us to be successful in those environments, which could be dependent on the noise exposure that we might have, or even the situational awareness that we're put in those environments that cause us to have different attentional capacity, fundamentally change how each of us experience every bit of sensory information at the lowest level, as well as up to our cognitive processing. And these differentials are critical to our technology, and yet, for the most part, the technologies that we build every day are really delivered, especially the ones that we use every day, are delivered in a one-size-fits-all approach. I like to give some, where I see in healthcare an acknowledgement that personalized medicine is critical. In contrast, we're in a place where the technologies that we're using every day, we're failing to acknowledge the ramifications of not providing personalization and not providing dynamic contextual optimization of those technologies. In a place where even, let me take what I consider to be a pretty simple example that we use every day and is completely broken for a majority of the population with regard to how that technology is delivering any of its intended use. Headphones. Seemingly innocuous technology. I mean, we're here talking about things that really have quite an impact on saving the world, and I'm showing you a pair of headphones. But not so innocuous. When you think about the fact that information delivered to our ears is going to be a critic, and the efficacy of this experience in enriching our senses, potentially providing an ancillary channel of critical information in future augmented reality technologies, or an ancillary channel of information with data sonification to pilots, or maybe even just a competitive edge to a gamer. But fundamentally, how we deliver spatial information and information that reaches our senses is critical to the success of every one of us in the future. And right now, we're not doing it. So it turns out to create an experience of spatialized audio, you have to include a model, a perceptual model of the transfer functions that our bodies impose on every sound we experience in the environment, okay? And right now, I like to say that this is pretty much a problem that's been broken for the industry for the entire, it still is. People are starting to think about it. I'm going to give you a success story here. But fundamentally, we've been building headphones for white men and snowmen, is what I like to say, which a snowman technically is a white man. But what's been delivered is a one-size-fits-all model. There have been two approaches, basically, that people do. You have to have a model that takes that transfer function that's imposed by our bodies, by the convolutions of our pinna, and what series of amplifications and attenuations for every point in space, that has to interact with your algorithms. And historically, they've done it two ways. Either they've used physical modeling and treated the head as a sphere, thus our snowmen, or they've based it predominantly on a physical model derived by a European male, and use the series of attenuations, and you may know this as a head-related transfer function, but use that series of attenuations and amplifications as a way to simulate spatial audio. And guess what? We're all different, okay? Every one of us is different. The way that our physical shapes affect the unique filters of information from the external world change our internal experience of that information. And historically, it's never been personalized, namely because people felt that the way we would capture a head-related transfer function involved many hours spent in an anechoic chamber, days, and still you ended up with a noisy response because people were not very good at staying still. You can look at the data, and if we even just take something as simple as a principal components analysis and color code it by gender, where we're looking at the anthropometry of males and females, and also the information contained in the HRTF, in that transfer function, and color code it just based on gender, it's linearly separable, basically. You can do the same thing with different ethnicities. Okay, my point here is that, look, this is a technology we use every day. What we're actually delivering to individuals is completely different. There's absolutely no consistency in terms of how anybody experiences really any of that content. When we look at how this affects information, I mean, these are just systems we can look at. This is the exact same systems across 4 different individuals of information that should be providing them accuracy in where a sound is represented to them, which could be something providing them some piece of critical information that they should act on. And the red dots indicate where that sound is supposed to be, and the others is where they actually perceived it. The only thing I want you to take away from this is everyone is very different. The types of ways this technology might break is not just minor, it's a degree off, it's fundamentally reversed. You get front-back confusions, you get collapses, but you get a complete breakdown of the system in a way that we haven't been able to personalize it. And it just points to how critical this type of personalization is and what's happened in the last 3 to 5 years, which is where I start to see success stories and how we're integrating and thinking about the relevance of internal experiences as a critical part of our technology. So in the last 5 to 10 years, 3D structured light has become mainstream consumer capacity that we can use. Not only that, but we're starting now, it's showing up in mobile devices, it's showing up in form factors, where the age of not being able to personalize has enabled us to take a completely different approach to solving a problem where we can throw, with 3D structured light, appropriate machine dimensionality reduction with machine learning models, and computer vision, we can personalize a head-related transfer function in a matter of seconds to minutes simply by 2D capture from a mobile phone. Okay, so 3 years ago, this wasn't done. Now it's done. And it's just starting to get to the point where what we're able to do is move in a direction of personalized content and personalized experiences. We spend so much time thinking about how we standardize, objectively standardize the experiences of our technology, how they behave, but we never, seldom, I'll say seldom, we seldom care about the actual intent of those experiences and how they're translated to the individual and experienced. So I've spent most of my life prior to becoming a technologist as a systems neurophysiologist. And I like to think that many of the questions we think about as systems neurophysiologists are very similar to the same ones I think about every day now, which is, our understanding is we're always trying to understand the neural translations that happen from the physical world to the physiological world to the perceptual world. And we want to know, what information matters that gets us to that perceptual experience? What artifacts arise? What neural coding strategies best preserve those key features that enable us to make that transformation? Because what we really care about is that perceptual experience. So I spent a lot of time doing that in the brain at many different levels. And now I think about the same things, but with a different content stream. So we're thinking about what are those dimensions that preserve and transmit, the most important aspect of a creator. When someone's creating content or creating an experience, how do we assure that that is translated to each and every individual in the same way, that their internal experience of that information is going to be the same? And it's not just about the creator. I think of, it's also about the developer of a technology. How do we assure that the technologies we're building are actually being experienced by individuals in the same way, in a way that's democratized, so that the benefits are translated? There's sort of three different things to get to this path. And we've touched on a lot of them today, but I like to separate it into control, insight, and creation. Where control is predominantly about, we have to have the sensors and the predictive and the knowledge to build a predictive model of perception that enables us to develop technologies that can anticipate how human perception is going to change under different contexts and conditions. So for example, I want this illusion, a variation of illusion that I built. I want you to stare up into the sunlight in a moment. And if you're looking at the sunlight off and to the right, you should probably see some bubbles floating up. Those bubbles are floating up, and they seem to probably fly off the screen, right? All right, so if you shift your gaze and look directly at the bubbles, you should probably realize now they're floating straight up, right? So depending on where your gaze is shifted, the bubbles either appear to go up and fly off the screen, or they appear to rise vertically. Does everyone agree? All right, so simple illusion, but there's a point here that I want to pull out, which is, we know what's happening. We know that this is about a conflict between our local and global motion. I've got a horizontal gradient that's moving across the bubbles, and that's in conflict with the vertical motion that's rising above. When those bubbles fall in your foveal vision, you can resolve the differences between the two motion trajectories. When the bubbles fall in your peripheral vision, where actually you experience an integration of the two trajectories, and the bubbles appear to go off on an angle. But this is a place where your internal state is dependent on your gaze. So a sensor is something as simple as just knowing where someone is looking, immediately closes the loop and gives us a really critical insight as a developer, as someone who might want to optimize an experience or critical knowledge to what the internal state of the user is. And that's starting to get to a control model where we can think about something more dynamically, but it's really quite limited in where we want to be. So with much deference to what's gone on here, I wanted to take you through some of the ways that we're thinking about how we go past the control model to really capturing richer experiences about the internal experience of the user, and how those are, how we're using them to think about them as an interface for control of the systems that we're intersecting. Because ultimately, our technology needs to respond not just to our predictive model of human perception, but to our internal experiences in a way that are dependent on our biology, on our context, and on our priors. When we think about what's happening with ubiquitous sensing, it's not, I think many of us have been using pupillometry and ways of catching these deterministic signals that we give off as humans and other species in many different forums for years. But the nature of how small, how prevalent, the computational complexity of the amalgamated sensing that is showing up everywhere and reaching us in consumer devices is enabling us to be such transform how we think about the capture in time of this information. So for example, your eye responds to how hard your brain is working and is a very insightful window into cognitive load. So just watch, try to understand the two talkers and watch the diameter of the pupil. All right, so the pupil has become a very interesting place. But what you would have heard here in this simple example is simply two talkers. It starts with two talkers. You pick up on the cognitive load, and your autonomic nervous system drives your pupil to dilate when you're under a condition of cognitive load, and and it contracts when your brain's not having to work as hard. We can see that in different ways. We can, obviously see it with multiple talkers under a cocktail party sort of situation. We can also see it with spatialization, where simply spatializing the talkers, you can see that in that kind of response in the pupil. And then that becomes an interface for how technology is behaving to assure that, we're not just targeting the standardized objective output of the technology, but instead that's closing the loop to better inform the technologies that we're developing in real time. One story that I like to tell is, when we were developing some of our imaging technology, and this was about 8 or 9 years ago, I was working a lot with high dynamic range imaging. And one of the things that I realized, so I was watching, your typical standard dynamic range display is about 300 to 400 candelas per square meter. But we were working with imaging technology that got up to, say, 7,000 to 10,000 candelas, and even higher, in some cases up to 20,000 candelas per square meter, where the natural moon is about 1,000 to 2,000 candelas, and in many cases, your sunlight on black pavement gets up to about 15,000. So in this situation, suddenly you have, like, you're experiencing content, experiencing things in ways that your brain has never seen them unless it was actually real content. And watching this flame, I actually felt my body react. And I felt it react to fire in a way that was surprising. My initial reaction was it must be the fact that the display is giving off heat. But in fact, it was not. So we got out thermal cameras, measured the display, it was completely constant. And then we realized, okay, I can go and I can actually track regions of interest on people's faces to their thermal response and pick up changes in how the dynamics of their facial temperature in response to flame, which gave us this great insight that, look, when I wander the world as, just as an individual with, my priors of interacting with flame and fire, my body's already expelling heat before I even feel it, just dependent on my expectation that that's flame and the fact that the luminance reaching my retina is as bright, crosses a certain threshold. So in this way, we were able to show, okay, this thermal response is able to trigger an internal experience that is touching and integrating us with our natural environments in a probabilistic manner. But then also we started looking at the dynamics of thermal response as a really interesting non-contact sensor that integrated, that tells us a lot about the human experience. So looking at the derivatives of facial response to different contexts, different stimuli, we're able to track, see changes in response to stressful stimuli, changes in response to engagement. And it becomes, it tells us a lot about the information that we're radiating from our bodies about our internal experiences. And we find this particularly powerful because, again, it's paired. It's all about how we pair this information. Again, we've seen beautiful things happen here at MIT with facial recognition and some of the things that how we capture emotion. But pairing this with semantic applications that we pull out of different the information from microphones, as well as cognitive load that we pick up in the eye and in the ear, and the information that we're capturing from the dynamic signatures that we are deterministically sharing. A huge transformation has happened in the last 5 years regarding how richly we understand the statistical dynamics of our voice and speech tell us about our mental and physical health. It's the integrative capacity of technology to give us great insights in ways that, as humans, we're not good at. We're not good at noticing trends and noticing shifts. We're good at enabling ourselves to perceptually action on effectively in an environment. And often that means that we don't pick up on subtle changes that happen across time to our underlying physiology. An example I often give in that case is, with regard to acoustic neuromas, which, a tumor that grows on the nerve. Many people don't even notice an acoustic neuroma until they have about a 40 to 60 dB unilateral hearing loss. And it's because of that integrative capacity that we have to not notice differences. And what we've started noticing, many different groups, and we've been looking at, is the number of conditions that our voices provide information about. So groups have shown with artificial intelligence. Are we okay? Because I have a little, okay. With artificial intelligence, groups have shown with artificial intelligence, they've been looking at the syntactic complexity and semantic coherence of voices that you can predict, obviously, schizophrenia, dementia, Alzheimer's. Many different changes in our health show up simply in the spectral coloration of our voices. And these are all things that simply by the information that we're able to track and have with technologies that were already on us and in our environments can give us great insight that can be reactive. It's there are many privacy issues, obviously, that you're thinking about. I work a lot in standards and regulation, but it's such an opportunity for democratized diagnosis to get people that otherwise do not know, would not know that they need to be, they should be seen or can be seen to at least a practitioner in a way that we can enable a great opportunity for earlier intervention. But it's also this acceptance that devices will know more about us than we do. Our speech, our dynamics of our voice radiate the exhalant that we share when we are experiencing fear, joy, suspense. It can be tracked in the chemical composition of our breath. Each one of us, when we're in an environment, you can pick up changes, whether our heart's speeding up, whether our muscles are tensing, but all without major changes in our overt behaviors. These show up as changes in our chemical composition of our breath. We've looked at changes in, predictive changes in carbon dioxide with suspense and fear. You can see this, I think, it's a very powerful tool when you consider a crowd that we actually broadcast the chemical signature of our emotions, and that this is a dynamic signature that's constantly changing. A few places where groups have shown the changes in, just pardon, may I finish? I have just a few more minutes, and I just want to make sure it's okay. Okay, is that okay? Thanks. Okay. That I thought was particularly nice and interesting is here where, these are different audiences in response to, they're watching the same content, they're watching Hunger Games, and you can perfectly predict visually the moment in time where Katniss's dress catches on fire, simply by looking at either multiple exhalants. You can look at carbon dioxide and also acetone, and you're getting this predictive shift in the crowd to the chemicals that they're breathing. One place, so I've talked a lot about how we're using and thinking about these different senses, different metrics of capture that can be integrated and amalgamated to give us dynamic interactions with our technology in real time. My past life, I had a great experience, a great many of years. I've worked with a lot of species, but I spent quite a bit of time working with the common marmoset New World monkeys. And marmosets are interesting. So marmosets are native, they're New World monkeys that are native to Brazil in the Amazon. And when one sense is compromised, or say, the information you're getting from that one sense is not particularly informative, your other senses, you develop different ways of communicating. So obviously, they're arboreal. There's a lot of foliage in the trees. Marmosets have incredibly rich vocalizations and ways of communication. But they also have something interesting. They have a very rich pheromonal social interaction in the colonies of, and they have a dominant social structure. So the dominant female within a colony secretes pheromones. Those pheromones actually show up as driven by her mental state, causes the ovulation within the social colony, the ovulation of all the other females to suppress. Okay? You can take a female out of that colony and put her in the same proximity, but now with a different mental state, a different social structure, and she'll start ovulating in very near time to the shift in social dynamics. Now, I'm not trying to suggest that I think the data right now is quite strong that at least human pheromones are not driving our interactions, at least not supported if defined as we currently define them. Nonetheless, one of the things we're particularly interested in, when we're touching and understanding emotion, because we touch a lot of interesting emotional stimuli, is excluding overt behavior. Better understanding, influencing through immersion and emotional valence, the signatures that we share biologically, the deterministic signatures that we share chemically and biologically that influence our social dynamics and emotional states. So for example, I apologize for making you watch this. I think this is Mad Max, which is fairly violent content, but I don't know that the sound is going to work now. What we're looking at here is, so we have two different groups where we're looking at, we're trying to understand the physiological coherences that change in social viewing versus solitary viewing, because there's a very different impact of information when we're experiencing it in a social crowd, and how that affects our technology is a critical part. The sound is actually an important part of this, but this terribly violent, maybe it's nicer to watch it this way. Okay, so that big explosion, so people are watching this explosion in groups and in solitary conditions. And here's another example of a clip. But they were watching this embedded in larger scene from Mad Max. But there's this point right here where the woman's throat is grabbed. So where we get to here is looking at, this is a quick metric, but of global field power for EEG, looking at neural coherence. What we want to know is the coherence that happens outside of overt behaviors and how that changes in these emotional impactful settings. And you can see in the group setting very distinct and significant changes in the coherence dependent on these high valence conditions, which tells a lot about where we're moving to when we start thinking about, people have talked about here and the ways that how we capture the link between our chemical and social interactions, how those are changing and how they're going to interface our technology. So with some of the work that we're doing, we're starting to be able to touch, we're looking at the correlates of these deterministic biological and chemical behaviors and how they show up. But we have a very unique place to be able to reach quite emotionally impactful technology where we can track many different physiological signals in quite natural behaviors for individuals. And to close, I mean, it is the end of the poker face in many areas, and I like to call it the era of the empath, where we've talked a lot today I think about personalization and internal experiences, but it's where those internal experiences become an integrated dynamical part of the controls and dynamic system at all points in time for how technology is realized and how it's making its deterministic answers to what it drives and how it behaves and how it changes and modifies its state. We're moving sensors into the environment as opposed to on us, and we're able to then create spaces that will become dynamic partners for optimizing our cognitive capacity as well as our physical capacity, dependent on context and internal experience. And how we use the amalgamation of that information is very critical to the success and efficacy of each individual. I'm not so concerned. I mean, when people talk to me about bias in AI, which I think comes up in many places, the answer to that is to track internal experiences, because the more we track and integrate the internal experience of a user into that dynamic probabilistic equation, the more likely it's the only way, as far as I'm concerned, you're going to assure that the technological benefit of that is reached. Because right now, we're in a place where so much of consumer technology benefits a very small part of the population. And there's no tracking. There's tracking for how that technology should behave, not tracking for how it actually intersects the experience of the user and whether they're actually having the experience intended by the developers. And that's a very different approach to how we solve these problems. My work at Stanford is entirely focused on neuroplasticity and how technology reaches us and engages with us. And in those ways, we build a lot of immersive environments that are iterative, focused on neuroplasticity for rehabilitation, focused on neuroplasticity for when we're able to create different environments, whether with the benefit of AR or any other technology that enables embodied user control. But fundamentally, looking at where we were with plasticity 15 years ago, we thought about it quite differently. I think today we can think about it as a tool. And it's a very powerful tool because all of our technology is going to influence how our brains develop and how they shape. And building that thought into developers and into the technology industry, both for the ethics and ramifications of how we want to proactively shape the capacity that we have as humans and how we interact with each other is, I think, a mindset shift that hasn't existed but needs to exist going forward. So I'll leave you with that and one quote, one thought, which is, closing the loop on entertainment. Leo Tolstoy defined his perspective on what art was dependent on the link between whether the creator's intent was realized by the receiver on the other end. And that defined in his mind, I think many artists I know disagree with this, but defined in his mind what it really meant for true art. And obviously today we can know that. We can know whether intent is experienced in many different ways. But it comes with a really fundamental shift in how we define what our stories are. Not just our stories in the creative space, but the stories that we interact with each other, and also the expectations that we all are going to have, and our users and the people we socialize with and our patients are going to have with how we define the expectations of technology with regard to trust, with regard to authenticity. It's an unprecedented era of authenticity that's going to create a very different exchange. And I think we have to be very proactive in how we think about that. Thank you.
Thank you.